This example is on the margin of error and the population proportions. So first of all, there's two key formulas that we're going to need. We're going to need this one here for, first of all, for example 1. It's called the margin of error formula. Error is equal to 1 over the square root of n, where n is the sample size. And then the second formula we're going to need is this one here, which is for the confidence interval. So it's a 95% confidence interval. What that means is it's going to be correct 95% of the time. And it's going to give us, we can't find out an actual population proportion since it's going to be impossible to sample everybody. But what we're able to do is take a sample proportion and plus or minus the error from that, the error formula which we've calculated already. So we're able to be confident 95% of the time the value is going to lie between these two particular answers. You'll see a bit more detail when I go through an example. Example 1. What sample size would be required to have a margin of error of 0.05? So we actually know the margin of error. So error is equal to 1 over the square root of n. If we know that that is equal to 0.05, we're now trying to solve for n. First thing we're going to have to do is square both sides. If you square both sides, this left-hand side goes to 1 over n, and the right-hand side squaring this here, you can leave it as 0.05 squared. And then what we'll have to do is multiply both sides by n, get rid of the n in the bottom. So then you're left with 1 is equal to 0.05 squared by n, and then divide by the 0.05 squared. So it's going to be n is equal to 1 divided by 0.05 squared, which is equal to 400. So 400 people were sampled. Same kind of idea for the second one. It's going to be 1 over the square root of n is equal to 0.025. So that's what 2.5% is as a decimal. So it's going to be square both sides. 1 over n is equal to 0.025 squared. Skipping down through some of the steps, we can see that n is going to be equal to 1 over 0.025 squared, which is equal to 1600. So 1,600 people were sampled for that particular example. Moving on to example 2. I'm going to leave my formula up above here. Like I said, this is the confidence interval formula. You're going to need to learn it for the exams, but once you do a few examples, it's not that hard to learn off. So example 2, a random sample of 400 persons are given a flu vaccine and 136 of them experience some discomfort. Construct a 95% confidence interval for P, the population proportion who might experience discomfort. Now, out of a sample of 400 people, 136 felt discomfort. Now, if we wanted to figure out how many people out of everybody would find some discomfort, to find it for the true population proportion, we're going to do a confidence interval. And this confidence interval is going to work 95% of the time. Okay, so we're going to use the margin of error as an approximation first of all. So the first thing we need to do is find what p hat would be. So this is going to be the sample proportion. So the sample proportion is equal to 136 people who felt discomfort over 400 people in total, and writing that as a decimal at 0.34. We also need to work out what the error is going to be. So it's going to be 1 over the square root of n, which is equal to 1 over the square root of 400, and that is equal to 0.05. Seen that already in the example above. And then to actually construct the confidence interval, it's going to be p in the middle, and then we're going to use our formula. So it's going to be 0.34 minus the error, 0.5, and then it's going to be the 0.34 plus the error. So at the end, we can see that it's going to be between 0.29 and 0.39. So what that means is, so this confidence interval is going to work 95% of the time, between 29 and 39% of people are going to experience some discomfort from this flu vaccine. This is a third example. Again, it's quite similar to the previous one. A survey of 100 residents in the Dublin suburb were asked if they remembered seeing an advertisement for McCain's chips on television. 60 respondents said they had. So first of all, we need to calculate the sample proportion, p hat. So p hat is equal to the number of respondents who actually seen it over the total number of respondents. So that is equal to 0.6. To calculate the margin of error, we're going to use the formula, which is 1 over the square root of n, 1 over the square root of the number of people that were actually surveyed. 1 over the square root of n is equal to 0.1. And then to actually construct the confidence interval, it's going to be using the formula, so it's p hat minus the error, and then the true population proportion, and then it's going to be the sample proportion plus the margin of error. So the true population proportion is going to be 0.6 minus 0.1, and the other one is going to be 0.6 plus 0.1. So this true population proportion is going to be somewhere between 0.5 and 0.7. Okay, the confidence interval is very large here, but that's because the sample is small. If you had a larger sample size, so the larger the sample size, the smaller this number would be. Okay, so the bigger the number in the bottom, the smaller the number overall, so the smaller the margin of error, and then hence the smaller the gap between these two figures. So for this one here, it's saying that between 50 and 70% of people will see the advertisement on TV.